In numerical methods, we are using different kind of methods to find a roots or a point of a given functions. The procedure and the algorithm of these functions or the examples are second method. First, we are given an equations of x cubed minus 15x minus 8, and the initial guess is 3 and 5, which is x sub 0 and x sub 1. It's just a 2 point. So to get the value of x of f of xi, just substitute the value of x1, which is 5 raised to 3 minus 15 multiplied by the value of x1, which is 5 minus 8, which is equal to 42. Then to get the value of f of xi minus 1, just substitute the value of x sub o, which is 3. Then 3 over 3 minus 15 multiplied by 3 minus 8 is equal to negative 26. So for iteration 1, to get the value of x plus I, just substitute the formula, which is x1 minus f of xi multiplied by f of xi minus 1 minus xi over f of xi minus 1 minus f of xi. Then then x1 is minus 242 multiplied by 3 minus 5 over negative 26 minus 42, which is equal to 3.7647. So to get the percentage, just substitute the formula, which is the present x plus 1, which is 3.7647 minus the x1, which is 5 over the 3.7647 times 100. So the percent error is equal to 32.81%. So for iteration 2, just adjust the given point. So the x sub 0 will become 5 and the x1 will be 3.7647. So just substitute the value. For f of xi, just substitute the value of the new x1, which is 3.7647 raised to 3 minus 15 multiplied by 3.7647 minus 8, which is equal to negative 11.1135. For f of xi, for f of x minus 1, just substitute the value of the new x0, which is 5. So 5 raised to 3 minus 15 multiplied by 5 minus 8 is equal to 42. So to get the value of x plus 1, just substitute the value of the 3.7647, which is the new x1 minus the new f of x1 multiplied by 5 or the old or the new x0 minus the x1 over f of x I minus 1 plus the new x1, which is 11.1135. So the value is the value of x plus 1 is 4.0231. So to get the percent error, just get the present x plus 1, which is 4.0231 minus the past, which is 3.7647 over the present, which is 4.0231. So the value is 6.87%. This is the example of false position method. First, we are given an equation, which is x cubed minus 15x minus 8. First, we assume an x lower and x upper. The x lower is the 3 and the x upper is 5. So to get the f of x of L, just substitute the value of x lower, which is 3 raised to 3 minus 15 multiplied by 3 minus 8, which is equal to negative 26. So to get the f of x upper, just substitute the value of x upper, which is 5 raised to 3 minus 15, multiplied by 5 minus 8, which is equal to 42. In postposition method, we are going to find the x root. So the formula for finding the x root is this: x upper minus f of x upper times f times x lower minus x upper over f of x lower minus f of x upper. So by substituting the value that we get, by substituting the value that we get to the formula, we can come up with this answer. F of x root is equal to 3.7647. So this is the example of Newton-Raphson method. So we are given certain functions, which is x cubed minus x minus 2. So just derive these equations. So the value of f of x prime is equal to 3x minus 2. So for getting the f of x of n, just substitute the value of the initial guess, which is 2. 2 raised to 3 minus 2 is equal to 4. So f of x of n is equal to 4. And get the value of f of x of n prime by substituting the initial guess, which is 2. So f of x of n is equal to 3 times 2 squared minus 2 is equal to 7. So 7. So by getting the, for iteration 1, just get the value of x of 1, which is equal to xn minus f of x of n over f of x of n prime. So x1 is equal to the value of the initial guess, which is 2, minus the f of x of n, which is negative 4, over f of x of n prime, which is 7, is equal to 1.4286. So our new f of x of n, or our new x of n, is equal to 1.4286. So for iteration 1, use that xn to get the f of x of n. By substituting the xn, we come up with the 1.4286 raised to 3 minus 1.4286 minus 2 is equal to negative 0.5129. So for getting the f of x of n prime, substitute the value of x sub n, which is 3 times the value of x sub n, which is 1.4286 squared minus 2 is equal to 4.1227. 4.1227. To get the percent error, just multiply the x sub n, which is the present x sub n, which is 1.4286 over or minus the past, which is 2, over 1.4286 times 100 is equal to 28.57%. Then use the, for getting the x sub 2 for iteration 2, just follow the formula, which is x sub n with the new x sub n, which is 1.4286 minus the f of x n, which is negative 0.5129 over the f of x n prime, which is 4.1227. So the value of this formula is 1.5530. So by computing the percent error, just put the present xn, which is 1.5530, minus the past, which is 1.4286, over the present, which is 1.5530, which come up with the answer of 8%. So this is the example of bisection method. In bisection method, we are given an equation. To solve this given equation, we just take initial guess of x lower and x upper. The x lower is 0.5 and the x upper is 1. To get the x mid, just add the x lower to x upper over 2. So the answer is 0.75. That is the x mid. To get the value of f of xl, just multiply the x lower cube minus 2 multiply to the x lower, which is 0.5 minus 1. So we come up with the answer of negative 1.875. So to get the x mid, just use the formula of the x mid raised to cube minus 2 times the value of x mid, which is 0.75 minus 1. So the answer is equal to negative 2.0781. So in algorithm, the condition if the f of xl and f of xm is greater than 0, we just use the x mid to xl, which is 0.75, and the x upper will become the same. So to get the x mid, just use the formula of the new x mid, which is 0.75 plus the same x upper, which is 1 over 2. We come up with the answer of 0.875. So that's the value of that's the new value of xm, 0.875. So to get the value of f of xl, just use the new x upper, which is f of xl is equal to 1 cube minus 2, 1 minus 1 is equal to 1, negative 1. And to get the f of xm, just use the new xm, which is 0.875 cube minus 2 times 0.875 minus 1, which is equal to So this is the example of Gauss-Seidel method. In Gauss-Seidel method, we're going to find the percent error of the given functions. So let assume the value of x is equal to 0. The x sub 1, x sub 2, and x sub 3. So for iteration 1, for getting the value of x sub 1, we're going to use this formula. b sub 1 minus a sub 1 2 multiplied by x sub 2 minus a sub 1 3 multiplied by x sub 3 over a sub 1 1. So the value of this 2 is equal to 0. So the remaining number is the b1, which is 6, over a1 1, which is 8. So the value of this one is equal to 0.75. So that's the value of x sub 1 for iteration 1. 0.75. So for getting the x sub 2, just use this formula. So by substituting all the given number, this is the substitute number. So by computing this number, we come up with this one, 12 plus 4 multiplied by the value of x sub 1, which is 0.75 minus 0 over the a sub 22 is equal to negative 1.0714. That's the value of x sub 2 for iteration 1. Negative 1.0714. So for getting the x sub 3, use this formula also. And by substituting all the given numbers to this formula, we come up with this number, negative 4 or b3 plus 6 a3 a sub 3 1, which is 6, multiplied by x sub 1, which is 0.75 minus 4 or the a sub 3 2 multiply by x sub 2, which is negative 1.0714 over a sub 3 3, which is 16. So by computing this value, we come up with the answer of 0.2991. That's for iteration 1. 0.2991. So by computing the percent error of this value, we use the formula of percent error is equal to the present minus past over present. So by computing all the percent error, the present of x1, which is 0.75 minus past, which is 0, over the present 0.75 times 100 is equal to 100%. So 100%. So the value of percent error in x sub 2 is equal also with 100%. Also in x sub 3, the value of percent error is equal to 100%. So for iteration 2, just use this formula also. So by computing the value of x sub 1, we come up with 1.0497 and negative 1 point, and for iteration 2, for x sub 2, we come up with the answer of 1.1998. And for substituting the x sub 3, substituting the given number also, we come up with the answer of 0.29991. Rather 0.4436. So the given percent error of this value, present for iteration 2, present minus past over present. For percent error 1, the value of the present, which is 1.0497 minus 0.75 over 1.0497 is equal to 28.55%. For x2, the percent error of x sub 2 is equal to negative 1.1998 over our minus negative 1.0714 over negative 1.1998 is equal to 42%. So for iteration or x sub 3, for percent error of x sub 3 is equal to 0.4436 minus 0.2991 over 0.4436 is equal to 32.57%. So this is the example of Euler's method. First, this is the formula of finding the HO, the H1, the delta O, the delta 1, the A, the B, the C, and the x plus 3, which is equal to x sub 2. First, we're given an equations of x cubed minus 15x minus 8. First, and we are given a value of x, which is 3, 5, 2, which is x sub 0, x sub 1, and x sub 2. First, substitute the value of 3 or the value of x sub 0 to get the value of x sub 0, which is 3 cubed minus 15 multiplied by 3 minus 8 is equal to negative 26. Then get the value of x sub 1 by substituting the value. So we can come up with the answer of 42 and get the value also of f2, which is 2 cubed minus 15 multiplied by 2 minus 8 is equal to negative 30. So the value of f of x1 is negative 26, and the value of f of x1 plus 1 is equal to 42, and the value of f of x1 plus 2 is negative 30. So to get the A, we just need to use the formula of A is equal to delta 1 minus delta O plus H1 plus HO. So to use this formula, we just get the value of delta O of delta 1, which is equal to f of x2 minus f of x1 over h1. So this is the given equation or the given numbers. Negative 36 plus 22.667 over negative 1. So the value is negative, or the value is positive 13. So the answer for A is positive 13. So to get to B, use the formula of A multiplied by H1 plus delta 1. So this is the value. By substituting all the given number to the formula, we can come up with the answer of negative 75. So C is equal to f of x1 plus 2. So just copy the answer of f of x1 plus 2. So to get the f of x1 plus 3, just use the formula of x sub 2 minus 2c over positive b positive negative the square root of b squared negative 4ac. So by substituting all the formula, we can come up with the answer of 30.51.